So on the next two problems, we're asked to find a lot of information about the two graphs: domain, range, x-intercepts, y-intercepts, zeros, and some function values. To find domain and range, I want to focus on the arrows first. Notice that that one of my arrows is going up and to the right, and the other arrow is going up and to the left. So the domain is a set of all x values. So we're talking about how far left can my graph go, comma, how far right can my graph go. Because my graph goes left forever and then right forever, my domain is going to be all reals. Negative infinity, comma, positive infinity. My range, on the other hand, does not go down forever. It has a low value. The lowest value it can be is -3, comma, and it goes up forever. So the highest it can be is positive infinity. So because it is allowed to be equal to -3, because there's no open circle there, we put a bracket on the -3. So usually brackets on numbers, parentheses on infinities, unless you see a big fat open circle, which I don't. The next question says x-intercept. So you're going to look at the x-axis and look all the way to the left and to the right, and you're looking to see where your graph crosses the x-axis. And then all you do is list that. So my graph crosses the x-axis at -2, 0, and also at 1, 2, 3, 4, 0. Alright, the y-intercept is where my graph crosses the y-axis. So my y-axis is up and down, and it looks like it crosses at -2, and the way we write that is 0, -2. The zeros are basically the same thing as x-intercepts, but you write them differently. The zeros are written as a list, so -2 and 4. You can put a comma in there if you really want, but when I put a comma in there, sometimes people think it's an ordered pair, and it's not. So I put the word A and D in between them so that you can realize that it's just a list of numbers. It's the x-coordinate of the x-intercepts written out. And the last two problems are about function values. So if I have f of -3, that means my x is a -3. So I'm going to go to the x-axis at -3 and look up and down from there. And it looks like I have a point at -3, 1. So therefore f of -3 is equal to +1. On the next problem, we have f of +3. So I'm going to go to the right, 1, 2, 3, and look up and down. When I find the point at which x is equal to 3, I find the y value. The y value happens to be -1, so f of 3 is equal to -1. On my next problem, I again look at my arrows. My arrows may appear to be going straight up to some people, but all parabolas continue to go out forever. So this is truly going to go up forever and left forever, up forever, right forever. The domain, we're talking about the set of all x's, so it goes left forever, comma, right forever. So that's -infinity, comma, infinity. Those infinities always get parentheses. The range has a low value. The lowest value it could be is -1, 2, 3, -4, comma, it goes up forever, so that's a parentheses. And the -4 gets a bracket because it's a closed circle. My x-intercepts, we're looking at the x-axis, and on the x-axis it appears that I have 2 points at which my graph touches the x-axis, so those are my x-intercepts. It looks like one of them is at 1, 0, and the other one is at -3, 0. Now if I can get my x-intercepts right, I should be able to get my zeros right, because all you need to do is take off the ordered pair part and just write the x-coordinate in really either order. The y-intercept, I'm looking at the y-axis, and it looks like my graph only hits the y-axis once, which is normal. You should only ever have one y-intercept. That point is at -3, so I write that 0, -3 as an ordered pair. To find the function values, f of -1, I go to the x-axis at -1 and find the point at which my graph has an x value at -1. So my graph has a value of -1 at y equals -4, so therefore, because -1, -4 is a value, f of -1 is equal to -4. F of -3, if I go to the x-axis at -3 and it appears I have a point right there on the x-axis, so f of negative 3 is 0 because we have a point at negative 3 comma 0. On these next problems, it says to solve the following equation or inequality, write your solutions to inequality in an interval notation. Now, both of these problems are inequalities. The reason why I included equation is because that was written that way on your exact exam, so I just didn't want to confuse you, so I just kept all of the instructions exactly the same. But in this case, both of them are inequalities. So the first one is a less than which, because I have a less than symbol. So because it's a less than which, I'm going to take x minus 7 and sandwich it between negative 10 and 10. At this point, I need to solve for x. So I'm going to add 7 to all three sides of the equation, leaving the x in the middle. I'll have a positive 17 on the right side and a negative 3 on the left. So this is the answer in inequality notation, not interval notation. So you're not done here. So if I make negative 3 and 17, and those are open circles, so my solution would be sandwiched between negative 3 and 17. The interval notation would be parentheses, negative 3, 17 parentheses. My next problem is 2x plus 4, the absolute value, is greater than or equal to 16. So this is a greater problem. So I have an or in my problem. The rule says I take the inside, which is 2x plus 4, and I'm going to compare it to positive 16 and negative 16. Notice that one of the equations, everything's exactly the same on this side, on the right side. The inequality is still greater, the 16 is positive, all I've done is take off the bars. On the other side, I've taken off the bars, but there's two sign changes. The 16 changes from a positive 16 to a negative 16, and the greater than symbol turns into a less than symbol. So this is the rule that takes an absolute value equation and breaks it up into two equations without absolute values. Now that they don't have absolute values, I can go ahead and solve these. Each of these are going to be solved independent of each other, so I'm going to go ahead and solve the entire first problem. And that gets me x is less than or equal to negative 10. I know there's a negative in the problem, but I don't switch my inequality symbol because I didn't divide by a negative. The negative was on the numerator, not the denominator, so therefore I don't switch my inequality symbol. On the next problem, I subtract 4 on each side, and that gets me 2x is greater than or equal to 12. So x is greater than or equal to 6, and this is still or. This is the solution in inequality notation, but that's not what I asked for. I asked for it in interval notation. So I'm going to make a mark here at 6, and I'm looking at all the x's that are greater than 6, so that's to the right. At x is less than negative 10, that's a closed circle at negative 10, and things that are less than it is to the left. So the interval notation, I have two intervals. My first interval starts at negative infinity and stops at negative 10. That's a bracket because I get to include the endpoint. Union bracket because I get to include the endpoint at 6, comma, infinity. This is my interval notation for this greater problem. So for these next problems, I'm looking for the X-intercept and the Y-intercept. There's two ways of doing this. I can either graph the problem and then find the X and Y-intercept from the graph, or I can solve for the X and Y-intercept first and then graph. It doesn't really matter which way you like to do it. You can do it whichever way you want. I'm going to go ahead and find the X-intercept first and then the Y-intercept, and then I'm going to use those information to graph. So on this first problem, when I'm finding the X-intercept, I know that's some value comma 0. So if I plug in 0 for y, then I get 3x equals 3, and x is equal to 1. So I can plot 1, 0 on my x-axis. For my y, I'm going to plug in 0 for x. For my y-intercept, I know x is 0, so I'm going to plug in 0 for x, so that's 3 times 0 minus y equals 3. So that's 0 minus y equals 3, or just negative y equals 3. And then I can divide both sides by negative 1, and that gets me y equals negative 3. You could probably do this with a little bit less work if you wanted to use your finger just to cover up the missing value. That would also work. Once you have 2 points, you can connect them with a straight line, and you are done. Now, another way of doing this problem is you could take your equation 3x minus y equals 3, solve it for y. So I'm going to move the 3 to the other side, the 3x to the other side, which gets me negative y equals negative 3x plus 3, and then divide every term by negative 1. That would get me y is equal to positive 3x minus 3. So my m would be 3, or really 3 over 1. And my b would be negative 3. So I could put my pencil on negative 3 and count up 1, 2, 3 and write 1, and I'd still get the same equation of the line, but this way I would graph the line first, and then I could look at my graph and say, oh, the x-intercept is at 1, 0. Oh, the y-intercept is at 0, negative 3. Either way is fine. I don't really care if you graph first and get the x and y-intercept off the graph, or find the x and y-intercept first and then use that information to graph. It's all good to me. So for the next problem, x equals negative 3, notice that we only have one variable x. We don't have a y, which means we have a special case, which means it's either going to be a HOI, horizontal line, or a VUX, vertical line. So HOI stands for horizontal lines have 0 slopes and their equations look like y equals a number. Well, this one isn't y, is it? So it's not a HOI. So it's probably going to be a VUX, which stands for vertical lines have undefined slopes and their equations look like x equals a number. Well, this does, x equals negative 3. So that's going to be a vertical line. To graph this, I'm going to go to my x-axis and go to negative 3, because I know x is equal to negative 3, and draw my VUX vertical line right there. Okay, so there's my vertical line. Once I've drawn that, what's the x-intercept? Well, clearly negative 3, 0. Where does this graph hit the y-axis? Well, it's not. It's never going to hit, so you need to put none. Don't put 0. If you put 0, then I think that you think that it crosses at 0, 0, which is a location on the graph and not representative of none. So don't put 0, put none or NA or not applicable or something along those lines, though it doesn't exist. There isn't any y-intercept.